In this video, we're going to look at the dilution guided practice problems. You should already have attempted to work these problems on your own, and this will help you if you've made any mistakes to figure out what those are or to look and make sure that you've got your problems set up correctly. The first thing we have to think about when we are working with problems that involve molarity, if we think it's a dilution problem, we need to look and be sure. So let's look at an example. In this problem, it's asking us, go ahead and read the problem, and it's asking us to find the concentration of a solution prepared by mixing 10 milliliters of 18.0 molar sulfuric acid in enough water to make 0.5 liters of solution. It might be easy to think that because the problem has two volumes and a molarity, that this will be just a dilution problem, that any problem with those pieces of information might be a dilution problem. But when we get to the stoichiometry unit, which is Unit 9, that won't be the case. So you want to ask yourself, is this a particular substance that's being diluted to make a less concentrated amount of the same substance? So looking at this, we have 10 milliliters of 18 molar solution, and we're trying to find the concentration of a solution if we add enough water to make 0.5 liters. So that is definitely a dilution problem. So the big question is now how we pair things up. So we want to consider which molarity and volume go together, because we know that the equation that we're going to use, M1 V1 equals M2 V2, is on your reference table, remember. We need to consider which two items, our molarity and volume, go together. It's a sure bet when you see 10 milliliters of 18 molar solution that those two numbers go together. And we can assign those whatever numbers we want. It doesn't matter whether we say that this is V1 or V2, as long as we give the corresponding molarity M1 or M2 to this number. So for the sake of argument, let's call this V2 and M2. And if we look, we have a volume, 0.5 liters. That would make this V1. And so for our concentration, we need to find M1. So let's solve it algebraically. Get M1 by itself. We're going to divide both sides by V1, and these two will cancel. And you can see that M1 is going to equal M2 V2 divided by V1. Now, we can go ahead and set it up with the numbers that are already in the equation. So if we say that 18.0 molarity and 10.0 milliliters, and then we want to divide by our V1, which is 0.5000 liters. And you can see right away that we're going to have a problem. Our milliliters will not cancel liters and leave us with the unit of molarity, which is what we need. So in this case, we are going to have to convert either the milliliters to liters or the liters to milliliters, whichever one is easiest for you. And if you can do that in your head, that's fine. If not, go ahead and work it out Dr. Label. So let's go ahead and convert our volume on the bottom, the 0.500 liters, to milliliters. So we want liters on the bottom, milliliters on the top. Remember that our scientific notation goes with our base unit, the one without the prefix, so it goes on the bottom. And that gives us 500.0 milliliters. So now we can just come in and substitute. Our M2 is going to be 18.0 molar. And our V2 is 10.0 milliliters. And then our V1 is going to be 500.0 milliliters. And when we work that out on our calculator, we should end up with 0.360 molar. So make sure you can see that the milliliters will cancel, and that gives you molar or molarity for your unit, moles per liter. And the correct number of sig figs, we have the smallest number in our problem, smallest number of sig figs in our problem is 3. Let's attempt the next problem. In this case, go ahead and read the problem. Don't freak out because there's so much information. Just read it and try to figure out how we're going to pair things up here. So now that you've read the problem, we want to look at what numbers will go together. We've got 5 milliliters of a stock solution. A stock solution is something that you purchase and use to make dilutions. And we have diluted that 5 milliliters to 2 liters. This solution that we've made up is later found to have a concentration of 0.0112 molar. So the way that we need to pair this is that we need to give, this is the molarity that goes with this volume, because this 2 liters of solution is the solution that we're speaking about that is found to have the concentration of 0.0112 molar. So let's call this, for the sake of argument, we'll call this M2 and V2, which makes this volume V1 and the unknown concentration M1. So again, we start with our dilution equation, M1V1 equals M2 V2. And we're going to go ahead and get M1 by itself, divide by V1. Those cancel. So M1 equals M2 V2 divided by V1. And then we can go ahead and remember that we'll need to go ahead and change our milliliters to liters. Our volumes don't have the same unit. You can change your 5 milliliters to liters. And if you do that, it would be 5.0 milliliters. And we need milliliters on the bottom, liters on the top. Milli is 1 times 10 to the negative third, and that goes with our base unit. And if we do that, that gives us 0.0050 liters. You can also do it the other direction, go from liters to milliliters, whatever you're most comfortable with. And then we just substitute in our numbers. 0.0112 molar for M2, and our V2 is 2.00 liters. And then V1, remember we use our converted number, 0050 liters. And you notice that our liters cancel out. That leaves us with our unit of molarity. We erase there. That pen just gets carried away sometimes. That leaves us with our unit of molarity. And the answer here should be 4.5 molar. Remember, only 2 sig figs in your problem.